ሰላም ሰላም ውድ የአስረኛ ክፍል ተማሪዎች እንዴት ናችሁ? ቲቸር ሰላም ነኝ። ዛሬ የምሰራላችሁ ለእናንተ የሚሆን ጥያቄ ነው። ዩኒት 4 ማጠቃለያ ጥያቄ ሰራላችኋለሁ። አብራችሁኝ ሆኑ። የመጀመሪያው ጥያቄያችን ስቴት ክሎምፕስ ሎው ይላል። ስቴት ክሎምፕስ ሎው ክሎምፕስ ሎውን ስቴት አድርጉ ነው የሚል ክሎምፕስ ሎው is a law which explains the relationship between charges and electrostatic force. You see, there is a charge. If you consider two charges within a variation distance r between charge 1 and charge 2, there is a gap distance between these two charges r. Then, according to Coulomb's law, the interaction force between charge 1 and charge 2 will be explained like this. Electrostatic force, which is the interaction force between charge 1 and charge 2, is equal to Coulomb's will have direct relation with what? The product of charge 1, charge 2, the product of the two charges, and inversely proportional to the square of the gap distance between charges, square of gap distance r square. So as to make equal side within this proportionalityውን ቀይረን ወደ እኩል የሆነን ሳይድ ለመውሰድ we have to apply Coulomb's constant. So electrostatic force is equal to Coulomb's constant K times the product of these two charges, charge 1, charge 2, charge 1, charge 2 over the variation distance r square. This is Coulomb's law, which is the relation between the product of charge and the gap distance square will be explained by Coulomb. So you have to state like this. Next to that, state the law of conservation of charge. Charge will be conserved. So if a charge is conserved, how can we state the law? Charge is conserved means charge neither created nor destroyed, rather only transfers from one body to another body. Since charges can be transferred from one body to another body but cannot be created or destroyed. Neither created nor destroyed, only transfers charge from one material to another material. You have to state the law of conservation of charges in this way. Next to that, explain about the different methods of charging body. You see, from here there are different methods of charging. Charging by rubbing or within a friction charging system, or charging by conduction, and charging by induction. So if you explain the charging system in this way, you have to explain it how it will be charged. Charging by rubbing means making friction for the two neutral bodies, and after charging the two bodies will develop opposite sign of charge. Charging by conduction means charging the uncharged body within a charged body by making contact with each other and transfers charge. After charging, the two bodies will develop the same sign of charge. Charging by induction means charging uncharged body by nearby a charging body without touching, and after charging the two bodies will develop opposite sign of charge. So you have to identify methods of charging in this way. Next to that, list electric safety rules. Safety rules in a sense, a rule that will use to protect the accident, or safety rules means a rule which helps us to avoid the accident. So as to avoid the accident, we have to use electric safety rules. So these electric safety rules will be important for electrical installation, or will help us to protect us with the danger of discharging electrons against cloudy season or within a thunderstorm. If there is a thunder, you have to make your electric safety, or you have to avoid from the danger of discharging electrons by what? By far from tall bodies, by avoiding staying within open fields, and by using shelter indoor, or you have to sit inside cars and or aeroplanes and closed every windows around the car or the aeroplane. So you have to protect yourself within the danger of thunderstorm by this way. When we go to electrical installation system, electric safeties are very important to avoid the accidents. You see, when we install electrical circuit, you avoid to touch the power lines with any material, and you have to make yourself in a safety rules. Next to that, two charges, charge 1 2 microcoulomb and charge 2 -4 microcoulomb, are placed 20 cm apart. Determine the magnitude and direction of the force that one charge exerts over the other. So as to calculate this force, you have to apply Coulomb's law. As you know before, Coulomb's will state that the product of charge will have direct relation with the electrostatic force. So you have to apply that force is equal to Coulomb's law constant K times the product of charge 1, charge 2 over the square of the gap distance between charge 1 and charge 2 square. So you see these two charges will be in opposite side, since you have to use the magnitude under absolute. Force is equal to, so as to calculate the magnitude of the electrostatic force, is equal to Coulomb's constant K times absolute of charge 1 times absolute of charge 2 over the gap distance R square. Absolute of any number is positive, since if charge is negative, the absolute of negative is positive. So you have to take force electrostatics is equal to Coulomb's constant, approximately K is constant 9 times 10 to the power of 9 Newton meter square per Coulomb square. So you have to substitute a number seems like this for K instead of K. So Coulomb's constant 9 times 10 to the power of 9 Newton meter square per Coulomb square times absolute of charge 2, since charge 2 is 2 microcoulomb times absolute of charge 2. Charge 2 is -4 microcoulomb, so -4 absolute of -4 is positive 4, so 4 microcoulomb. 4 microcoulomb እዚች ጋር 4 ማይክሮኩሎምብ ብለን እንተካለን ማለት ነው። ፖዚቲቭ ሆኖ ስለሚወጣ አንደር አብሶሉት ኦቨር the gap distance between the two is 20 centimeter. When we change the centimeter into meter, divide by 100. 1 meter is 100 centimeters, so 20 over 100, 0.2 meters the whole square. Then after, electrostatics force, magnitude of the force, that means micro means 10 to the power of -6. 10 to the power of -6 times 10 to the power of -6, the base is the same, so you have to add the hypotenuse. 10 to the power of 9 plus minus 6 plus minus 6 minus 12 plus 9 minus 3. Yes, 9 times 2 18, 18 times 4 72, I think 72 times 10 to the power of minus 3. This one clump times clump square will cancel this clump square. Meter square will cancel this meter square. Only Newton will be left. The unit for force, that means over 0.2 the whole square means 0.04. So Newton. You have to multiply both sides by 100 over 100 plus 2 here. By 4, 1 by 4, 80. So electrostatic force is 1.8 Newton magnitude. The magnitude of this electrostatic force F between charges is this one. Then what is the direction? If the charge is in opposite sign, charge 1 you see is positive and charge 2 is negative, opposite in sign. In a sense, there is force of attraction between these two charges. One will attract the other. This interaction force will in between these two charges is greater. So the direction force is the same. That means one will attract the other. Direction of the force, the electrostatic force will be in the same direction. So you have to understand that since the two charges will make attraction force, one will attract the other, so the direction of force between these two charges is in between the charge, so it is greater force will appear ብለን እንመልሳለን ማለት ነው። Next to that, two spheres 4 cm apart attract each other with a force of 1.2 times 10 to the power of 9 Newton. Determine the magnitude of the charge on each to see if one has twice the charge of the opposite sign as the other. እዚህ ጋር ሚለን 4 ሴንቲሜትር ፋር አፓርት የሆኑ ቻርጆች የመሳሳብ ኃይል እየተገበረባቸው ነው። ፎርስ ኦፍ አትራክሽን ቢትዊን ዘ ቱ ቻርጅስ ይሄን ያህል ማግኒቲዩድ ያለው ፎርስ ኦፍ አትራክሽን አለ ማለት ነው። ከዛ ዲተርማይን አማውንት ኦፍ ቻርጁ ስንት ነው፣ አንዱ የሌላኛውን እጥፍ ቢሆን ነው የሚለን። ስለዚህ ስንሰራ you have to set the equation in this way first. You have to state since the gap distance between these two charges, charge 1 and charge 2, the gap distance is 4 centimeter, and if charge 2 is twice of charge 1 then how much the electrostatic force is 1.2 times 10 to the power of 1.2 times 10 to the power of 10 to the power of 10 to the power of 9 Newton. 10 to the power of 9 Newton. 10 to the power of 9 Newton. So then what is the amount of the charge? Amount of charge ስንት ነው ነው የሚለና you have to use Coulomb's law. Force is equal to Coulomb's constant K times the product of charge 1 charge 2 over the variation distance r square. Since if the charge is determine the magnitude of charge on each to see one has twice the charge of the other within the opposite sign ነው የሚለን። ስለዚህ so if K charge 2 is twice of charge 1. Therefore, force is equal to Coulomb's constant 9 times Coulomb's constant K times charge 1 times twice of charge 2. Charge 2 means twice of charge 1. Yes, substitute twice of charge 1 over the variation distance r square. Charge times charge square. So charge ነው የምንፈልገው አሁን charge q is equal to force times variation distance r square over Coulomb's constant. charge square ነው charge times charge square. charge ለማግኘት under square root. Therefore አሁን substitute ማድረግ እንችላለን. charge is equal to the square root of what is force 1.2 times 10 to the power of 9 Newton times r gap distance between charges how much 4 centimeter ወደ ሜትር ስንቀይረው 0.04 meter the whole square 0.04 meter the whole square over 9 times 10 to the power of 9 Newton meter square per Coulomb square. Newton will cancel Newton, meter square will cancel meter square. Then what's left? Only Coulomb. So charge Q is equal to multiply them. 0.04 the whole square means 4 times 4 60. 4 yes. So the square root of 1.2 times 10 to the power of 9 times 1.6 times 10 to the power of minus 3 over 9 times 10 to the power of 9. 10 to the power of 9 would let's say minus minus 9 0 ይሆናል 1. then በ9 የሚቃለሉትን እናቃላለን. here you have by 3 by 3 0.4. okay, by 3 1 60 okay, 0.4 times 10 to the power of 0.4 times 1.6 1.6 times 10 to the power of minus 3 over all over 3 Coulomb ይቀራል ማለት ነው. so አሁን የሚባዛውን 4 times 6 24 under square root 24 4 times 1 4 plus 2 6 6.4 times 10 to the power of minus 3 Coulomb square under square root over 3 then divide by 3 1 by 3 2 6 by 3 1 3 1 10 3 3.13 or 3.13 times 10 to the power of minus 3 under square ይሆናል ማለት ነው. so you have to calculating charge as what? the square root of 6.4 times 10 to the power of minus 3 over 3 Coulomb. You have to calculating the value like this. So you have to considering how we use the formula to equating equations things like this, and generally you have to develop your ability to solve every questions regarding within a Coulomb's law like this. Next to that, two equal charges of magnitude 1.1 times 10 to the power of 7 Coulomb experiences an electrostatic force of 4.2 times 10 to the power of 10 to the power of 4 Newton. How far apart are the center of the two charges? አሁን ደግሞ የተጠየቅነው ምንድነው ጋፕ ዲስታንሳቸውን ቢትዊን ቻርጅስ ነው የተጠየቅነው። አፕላይ የምናደርገው የቅድሙን አይነት ጄኔራል ፎርሙላ ነው። ኤሌክትሮስታቲክስ ፎርስ ኢዝ ኢኳል ቱ ኩሎምብስ ኮንስታንት ታይምስ ቻርጅ 1 ቻርጅ 2 ኦቨር የጋፕ ዲስታንስ አር ስኩዌር ብለን ነው የምንሰራ። አሁን አርን ስለሆነ የተጠየቅነው አር ስኩዌር ኢዝ ኢኳል ቱ ኩሎምብስ ኮንስታንት ቻርጅ 1 ቻርጅ 2 ኦቨር ፎርስ ኤፍ ብለን ነው የምንሰራው አንደር ስኩዌር። ሶ አር ለማግኘት አር ጋፕ ዲስታንስ ቢትዊን ቻርጅስ the square root of Coulomb's constant K times the product of charge 1 charge 2 over the force F under square root። አሁን ቁጥሩ መተካት ነው። ቁጥሩ እዚህ ጋር የተቀመጠ ነው። ምን አለ ፎርስ አለ 1.1 times 10 to the power 7 ኩሎምብ ቻርጅ ነው። ቻርጅ መጠናቸው አንድ አይነት ነው ተብሏል። ኢኳል ቻርጅ ኦፍ ማግኒቲዩድ እኩል ማግኒቲዩድ ያለው ቻርጅ ነው። ቻርጅ 1 ቻርጅ 2 እኩል ናቸው 1.1 times 10 to the power 7 ኩሎምብ ነው። ፎርስ ደግሞ 4.2 times 10 to the power 4 ኒውተን ነው ተብለናል። ሶ generally you have to formulating and equate simply like this. R variation distance between charges equal to the square root of Coulomb's constant 9 times 10 to the power of 9 Newton meter square per Coulomb square times ጋፕ ቻርጅ 1 እና ቻርጅ 2 እኩል ስለሆኑ ቻርጅ 1 እኩል ስለሆኑ it is what 1.1 times 10 to the power of 7 1.1 times 10 to the power of 7 ኩሎምብ the whole square ይሆናል ማለት ነው። under square over force ስንት ነው 4 times 10 to the power of 4 4.2 times 10 to the power of 4 4.2 times 10 to the power of 4 Newton. So Newton will cancel Newton and Coulomb square will cancel Coulomb square, only meter will be left. So R is equal to the square root of 9 plus 7 60 then minus 4 12. So 9 times 1 9 times 1 9 9.9 1.1 square ስንት ይሆናል? for R the gap distance between charges is equal to some value here is 9 times 10 9 times 1.1 square ይሄም ስኩዌር ይሆናል 1.1 times 10 the power of 7 square times 10 the power of 9 over 4.2 times 10 the power of 4 ይሆናል ማለት ነው። ማግኒቲዩዱ ይሄን ያህል ይሆናል። አውጡት አሰራሩ በዚህ ልክ ነው የሚሰሩት ማለት ነው። እኔ ማሳያችሁ አሰራር ቅደም ተከተሉን ነው። ከዛ ቁጥር ስለሆነ እናንተ ቁጥሩን ማውጣት ትችላላችሁ ማለት ነው። የአሰራር ቅደም ተከተሉ በዚህ ልክ ይሆናል ማለት ነው። ሌላው discuss the use of lightning conductor that is often fitted to the top of the building ይለናል። ላይትኒንግ ሮዱን ማለት ነው። ላይትኒንግ ኮንዳክተሩን ከህንጻ ላይ የሚሆነው ጥቅሙ ምንድነው ነው የሚለው የመብረቅ መከላከያ ማለት ነው። ጥቅሙ ዲስቻርጅ ለማድረግ ነው። ኤሌክትሮኖችን ዲስቻርጅ ለማድረግ ሶ lightning conductors are very important when it is on top of building so as to make the cloud safely discharge. So electrons from the cloud can be discharged and how avoiding the danger of thunderstorm. within the building scenes. So it's very important to discharge the cloud safely. Next to that, why is not a bird sitting on high voltage power line electrocuted? Compare this with the situation in which a large bird hits two wires simultaneously with its wings. Why is not a bird sitting on a high voltage power line electrocuted? እዚህ ጋር አሁን የሚለን ምንድነው? የመጀመሪያውን ወፎች ከከፍተኛ ኤሌክትሪክ አስተላላፊ ከሆነ ፓወር ላይን ላይ ኤሌክትሮኪዩትድ የሚሆኑት ለምንድነው? ማይሆኑት ለምንድነው የሚለን በኤሌክትሪክ የማይያዙት ከከፍተኛ ኤሌክትሪክ አስተላላፊ መስመር ላይ ወፎች ያርፋሉ። ነገር ግን ኤሌክትሪክ አይዛቸውም። ለምን? አንደኛ የሚይዙት የሚቀመጡበት ከአንደኛው መስመር ብቻ ስለሆነ since the birds will sit on the single wire, so from that single electrical power line there is no potential difference. If there is no potential difference, there is no current to be flow within the circuit, since the birds cannot electrocuted ብለን እንመልሳለን ማለት ነው። Compare this with situations in which large bird hits two wires simultaneously with its wings ይላልና ይሄን ሲቹዌሽን ከዚህ ጋር አነጻጽሩት። ምን ማለት ነው? ሁለት በርዶች ሁለት ወፎች ኤሌክትሪክ ከሁለቱ ኤሌክትሪክ ዋየር የወፏ ክንፍ ቢነካካ ምን ትሆናለች? አሁን ወፏ ከሁለቱ ፓወር ላይን ላይ ክንፏ ከተነካካና ካረፈች የኤሌክትሪክ አስተላላፊ ሆና ነው የምታገለግል እንደ ፓዝ ላይን። so since the bird will use as electrical path lines ኤሌክትሪክ አስተላላፊ ትሆናለች። ነገር ግን በአጋጣሚ አንዷ ክንፏ ርግብ ካለ ወይም ከለቀቀ ሾርት ታረጋለች ማለት ነው። ሲንስ ልዩነቱ ከዚህኛው ጋር የመጀመሪያው ወፏ ከሃይ ፓወር ስቴሽን ላይ ስትቀመጥ ኤሌክትሪክ ማይዝበት ምክንያት አንደኛ የምትቀመጠው ከአንዱ ሲንግል ኤሌክትሪክ ፓወር ላይን ላይ ስለሆነ በዛ ላይ ደግሞ ፖቴንሻል ዲፍረንስ ስለሌለው ኤሌክትሮኪዩትድ አትሆንም ማለት ነው። ነገር ግን ሁለቱ ክንፎቿ ኤሌክትሪክ መስመሩን ሁለቱን የኤሌክትሪክ መስመር ቢነኩት አሁን በዛ ላይ ፖቴንሻል ዲፍረንስ አለ። ያን ፖቴንሻል ዲፍረንስ ደግሞ በወፏ አካል ውስጥ አልፎ ይሄዳል ማለት ነው። ስለዚህ ወፏ ለመስመሩ ታገለግላለች ማለት ነው። አስተላላፊ ሆና ታገለግላለች በመስመሩ ውስጥ የሚለውን ኮንሰፕት ያንጸባርቃል ማለት ነው። next to that, how is voltmeter connected in a circuit to measure the potential difference between two points ይላል። ቮልትሜትር በሰርኪት ውስጥ እንዴት ነው የሚታሰረው? ፖቴንሻል ዲፈረንሱን ለመለካት ነው የሚለን። በትይዩ ነው የሚታሰረው። part to the resistor ነው የምናስረው። Voltmeters must be connected in parallel to the resistor when the potential difference across the resistor will be measured. Since potential drop within the resistor can be read by the help of that voltmeter. Since voltmeter are instruments which helps to measure the potential difference, and at the same time it must be connected in parallel to the circuit. Since you have to understand the concept regarding like this. See, next to that, list one-way electric current in similar to water current, and one way is it different? List one way electric current is similar to water current, and one way is it different? ሚላዩበትንና የኤሌክትሪክ ከረንትና የወተር ከረንት የሚመሳሰሉበትና የሚለያዩበትን ግለጹ ነው የሚለን። ይሄ ደግሞ ጥያቄ ደግሞ አሁን ስንመልስ ኤሌክትሪክ ከረንት እና ዋተር ከረንትን የሚያመሳስላቸው ሁለቱም ኢነርጂን ይጠቀማሉ ስራ ለመስራት። both water current and electric current uses energy to do work ብለን መልሳለን። የሚያለያያቸው ግን ኤሌክትሪክ ከረንት ከኤሌክትሪክሲቲ ይሰጣል። ዋተር ከረንት ደግሞ ኤሌክትሪክ ከረንት ከኤሌክትሪክሲቲ ነው የሚገኘው። ዋተር ከረንት ደግሞ ከዋተር ነው የሚገኘው። this is the difference between these two. So you have to identify the similarity as what both electric current and water current use energy to do work, and electric energy is from electricity and water energy is from water ብለን መመለስ እንችላለን ማለት ነው። How does the current in the circuit change if voltage is doubled and resistance remains unchanged ይላል። How does the current in a circuit changes? በምን ያህል ነው የሚጨምረው የሚለወጠው ከረንቱ በሰርኪት ውስጥ ቮልቴጁ ዳብል ቢሆንና ሬዚስተንሱ ሪማይንስ ዘ ሴም ቢሆን። ይሄ ኦህምስ ሎው ላይ ታስተውሱ ከሆነ according to Ohm's law the voltage and current will have direct relation within the same resistance. Since voltage and current will have direct relation, that means if voltage is increased, current is also increased with the same resistance. So as to avoid this proportionality into equal side, voltage is equal to resistance of the material times current. Since if the voltage is double, what do you say about the current? Since if you consider this one is voltage 1 and voltage 2 is equal to resistance is the same current 2. You see, since voltage 2 is twice of voltage 1, you have to substitute here, yes? So voltage twice of voltage 1, that means voltage 2 is equal to resistance times current 2. So you must equating this towards this one, and you also avoiding the same sign. Voltage 1 over twice of voltage 2, voltage 1, this one is equal to resistance R times current 1 over resistance R times current 2. Resistance R will cancel by R, voltage 1 will cancel by voltage 1. What's left? 1 over 2. 1 over 2 is equal to current 1 over current 2. Since cross multiply after. What's current 2? 1 times current 1, current 2 is equal to twice of current 1. So you have to considering that if the voltage is double, the current is also double. You have to answer this type of question in this way. Double ይሆናል ማለት ነው። Next to that, a copper wire has diameter 0.5 millimeter and resistivity of 1.6 times 10 to the power of -8 ohm meter. What will be the length of this wire is to make its resistance 10 ohm? How much does the resistance changes if the diameter is doubled ይለናል። So you have to considering that first you have to find out the length of the wire. So you have to apply general formulas for material resistivity. Resistance is equal to resistivity of the material times length of the wire over the cross-sectional area. since resistance will have direct relation with the length of the wire and inverse relation with the thickness of the wire or the cross-sectional area of the wire. Since resistivity means the material, how much the material will resist the conducting ability. So then what will be the length? የተጠየቅነው አሁን ሌንግዙን ስለሆነ ምን ተሰጥቶናል? ዲያሜትሩ 0.5 ሚሊሜትር ተሰጥቶናል። ያው to apply ሌንግዝን አሁን ካልኩሌት ስናደርግ length of the wire is equal to resistance of the wire times the cross-sectional area over the resistivity of the material. What's area? Area is equal to pi r square. Since the diameter is 0.5 millimeter, the radius is 0.5 millimeter over 2. The whole square አድርገን እናገኛለን ማለት ነው። ሌንግዝን አገኘን። እዚህ ጋር መተካት ትችላላችሁ። ሬዚስታንስ 10 ኦhm ተሰጥቷል። 10 ohm resistivity ተሰጥቷል። ማቴሪያል resistivity ዲያሜትሩ ተሰጥቷል። ኤሪያውን ማግኘት እንችላለን። ሌንግዝ ካልኩሌት አድርገን ማለት ነው። ከዛ how much does the resistance changes if the diameter is double ነው የሚለን። ዲያሜትሩ ዳብል ቢሆን ሬዚስታንሱ በምን ያህል ይቀየራል ነው የሚለን። if the diameter is double, in a sense, consider resistance 1, you see, is equal to resistivity of the material times length of the wire over the cross-sectional area. Diameter, in a sense, you see, area ማለት area ደግሞ pi r square ነው። pi r square r ደግሞ ማለት diameter over 2 ነው። diameter over 2 the whole square አድርገን መተካት እንችላለን። so resistance 1 is equal to resistivity of the material times length of the wire over pi times diameter over 2 the whole square. Since if this one is diameter 1, diameter 2 is equal to twice of diameter 1. So you have to substitute. Resistance 2 is equal to resistivity of the material times length of the wire over pi times diameter 2 over 2 the whole square. Clear? Then substitute instead of diameter 2 twice of diameter 1. Then resistance 2 is equal to resistivity of the material times length of the wire over pi times what's diameter 2 twice of diameter 1. Double in a sense. Twice of diameter 1 over 2 the whole square. Then equating this one with regarding this one. Resistance 1 over resistance 2 is equal to what's resistance 1? Resistivity of the material length over pi times diameter 1 square over 2 square 4 all over what's resistance 2? Resistance 2. Resistivity of the material times length over 4 times pi 4 times 2 square 4 is 4 times diameter 1 square over 2 square 4. አሁን የሚጣፉትን እናጥፋ። resistivity with resistivity will be cancelled. Length of the wire with length of the wire will be cancelled. Pi by pi will cancel. Diameter 1 square over 4, diameter 1 square over 4 will cancel. What's left? 4. So resistance 1 over resistance 2 is equal to 1 over 4 in a sense. Reciprocal multiplication ብንጠቀም so resistance 1 is equal to resistance 1 over 2. Resistance 1 over resistance 2 is equal to 1 over 4 reciprocal. 4s. What's resistance 2? Resistance 2 is equal to resistance to creek cross እንደዚህ resistance 2 ስለሆነ የተጠየቅነው ማለት ነው። የዚህ over 1 አለ በስተታዋቂ resistance 2 ነው የተጠየቅነው። resistance 2 is equal to resistance 1 over 4. So it will be run 1/4 of the first resistance. በአንድ አራተኛ ይቀንሳል ማለት ነው ሬዚስተንሱ። ሌንግዙ ዲያሜትሩ ዳብል ሲሆን ሬዚስተንሱ ይቀንሳል ማለት thickness of the wire ከጨመረ ሬዚስተንስ ይቀንሳል ምን ጊዜ ያን አንደርስታንድ እንድታደርጉ ነው። ዲያሜትሩ ጨመረ ማለት thickness of the wire የገመዱ ውፍረት ጨምሯል ማለት ነው። if the thicker the wire the higher electricity to be passed within the circuit የሚለውን ኮንሰፕት አንደርስታንድ ታደርጉታላችሁ ማለት ነው። ስለዚህ ሬዚስተንሱ በአንድ አራተኛ ይቀንሳል ብለን እንደዚህ እንመልሳለን ማለት ነው። Next to that, if aluminum and copper wires of the same length are the same resistance, which has the largest diameter y ይለናል። አሉሚኒየም እና ኮፐር ዋየሮች ሌንግዛቸው አንድ አይነት ነው ይላል። እንደገና ሬዚስተንሳቸው ደግሞ አንድ አይነት ነው which has the larger diameter ይለናል። አሁን ይሄን አንደርስታንድ ለማድረግ ማቴሪያል ሬዚስቲቪቲያቸውን ነው የምናይ። ከአሉሚኒየም እና ከኮፐር ማቴሪያል ሬዚስቲቪቲው ከፍተኛ የሆነ የትኛው ነው? ከፍተኛ ማቴሪያል ሬዚስቲቪቲ ያለው ዲያሜትሩ ምንድነው ማለት ነው? ዝቅተኛ ነው የሚሆን ማለት ነው። ስለዚህ less conductivity ነው ያለው ማለት ነው። ከፍተኛ ሬዚስቲቪቲ ካለው less conductivity ነው ያለው። less conductivity ከሆነ ደግሞ ዲያሜትሩ ምንድነው የሚሆን? less conductivity ከሆነ ዲያሜትሩ ዝቅተኛ ነው የሚሆን ማለት ነው። ስለዚህ ከፍተኛ larger diameter ያለው ማቴሪያል የትኛው ነው የሚለና ማቴሪያል ሬዚስቲቪቲን ማወዳደር ነው። ስለዚህ ይሄን ደግሞ እንደዚህ አይነት ጥያቄ ስንሰራ ማቴሪያል ሬዚስቲቪቲውን መሰረት አድርገን ነው የምንሰራው ማለት ነው። ጀነራል ፎርሙላው ግን አፕላይ የምናደርገው resistance is equal to resistivity of the material times length of the wire over the cross sectional area ብለን ነው የምንሰራ። አሁን area 1 ይሄን resistance 1 እንበለው። since resistance 1 እና resistance 2 እኩል ናቸው ተብለናል። ሌንግዙ ደግሞ እኩል ነው ተብለናል። L1 is equal to L2 ተብለናል። አሁን resistance 2 ማለት ደግሞ resistivity of material length of the wire over area 2 cross sectional area 2 ዲፈረንሱ እዚህ ቲክነሱ ላይ ነው ያለው። ስለዚህ አሁን ኤሪያ ማለት ደግሞ ኤሪያ ማለት ፓይ አር ስኩዌር ነው። ፓይ አር ደግሞ ማለት ዲያሜትር ኦቨር 2 ዘ ሆል ስኩዌር ማለት ነው። ዲያሜትር ኦቨር 2 ዲያሜትር ስለሆነ